Hey everybody, this is Larry. This is day 26 of the Leetcode Day Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's farm. Maximum points you can obtain from cards. Okay, so there are cards in a row. And I hope you're doing alright on this beautiful Saturday. There's about 2 hours to the contest, I think, for me anyway. A lot of things going on in the USA, if you know, but yeah, we'll figure it out. Hope everyone's alright. Stay safe out there. But yeah. Anyway, today's problem is okay. So what does this mean? You have to get one card from the beginning to the end. You can take K cards. Okay. So this one seems pretty straightforward. Because I think the one thing that I always try to do is think about what is the naivest, or like what is the most. What is the solution that lets me prove the fewest things? And usually the first thing that comes to my mind is brute force. Sometimes maybe brute force in a slightly slicker way, but still brute force nonetheless, right? Yeah. And then the question is, well, if you're trying to brute force, what are you doing here, right? Well, if you try every possibility, all the possibility collapses to the same thing. I mean, one is that ordering doesn't matter, meaning that if you take one from the beginning and then one to the end, and then I think sometimes I don't say it explicitly, and I'm just like in my mind, I'm like, oh, it's so obvious. So definitely, keep on asking questions in the comments or in Discord, and I try to think about it in the future. But yeah, like I said, ordering doesn't matter, right? Like if you take one from the front and then one from the end, or the other way around, you take one from the end and then one from the front, it's still the same score. Hopefully that I don't have to do a rigorous proof there. I think this is, fairly obvious, maybe, or intuitive. I don't know if that's the better word. But yeah, and then the other thing is, I'm just writing very obvious and stuff. But yeah, so then the idea is, say K is equal to 3, right? Then the idea is, I just want to check the constraint real quickly. Yeah, then you could say take 3 from the beginning, then 2 from the beginning and 1 from the end, and then 1 from the beginning, 2 from the end, and then none from the beginning, and then 3 from the end, right? So that's basically really all you have to do. I think you could put, if you, depending on how, the thing I say is that during competitive contests and stuff like this, during contest, I would try to do what comes to my mind immediately and try to prove less. And maybe in this one, to be honest, I might do prefix sum and then just like a double prefix sum and then do a for loop, right? So that's easier. But of course, you can also do a sort of, I wouldn't say sliding window, maybe sliding window. Is it sliding window? I guess maybe a sliding window. Like there are a couple of ways you can do it, right? You could think about it as sliding window as K is equal to 3, meaning that, you have 4 inside, right, as the window. But really, I'm just thinking about 2 pointers from left and right. For me, that's more straightforward. But there are a lot of mathematically equivalent ways. So definitely, play around with the ideas, playing around with having different, outlook on the same problem, so that in the future, maybe you hit on one of those, if not, multiple, right? So anyway, but I'm going to do... I'm just going to write it out a little bit. Basically, I'm just going to keep track of the left sum and then the right sum, and then we'll see how that goes. So left sum is equal to 0, right sum is equal to 0. And then now we have 4 in range of K. So we look at we add the first, so then now, also we want to return the best for max. And so now we have the left sum, which is all of the prefix, right? And then we want to do left sum, or best is equal to max or best left sum. I guess there's no negative answer, or negative input, so it doesn't really matter. But yeah, just want to write that out. And then now we one at a time. We move it and then add it to the right? So then I guess left sum and right sum is a little bit awkward, but nonetheless, so right sum, we add it to points of, and I'm writing it this way just for kind of learning purposes. I probably would have tied in some of the code, but I don't know. That's up to you to decide whether I'm lying or not or whatever. But yeah, and then left sum, we want to subtract from card points of, was it k minus I, is that right? Or k minus I minus 1. And then now best is equal to best, left sum plus right sum. And you can think about the index easier this way with the variable names, hopefully, because this is now the k, for example, for k 0 to 3, you remove this one, and then this one, and then this one, and so forth, right? So yeah, and then now at the very end, obviously you should just return the answer. Let's give it a spin. Looks good. Let's give it a quick submit. Cool. Feel like it's been a while since I'm able to get it quickly, but nonetheless, 817-day streak, yay. As you can see, this is linear time, maybe even O of n plus k if you want to say that. Doesn't really matter. In fact, the function is okay. Maybe I could be more precise. It's like O of min of k and n, because technically you don't even look at the entire array, so this is actually able to be sublinear in that way. At least in the steps of the input, and then space is just O of 1 because we have n, which is just for yeast, and then some addition variables and a best, right? Anyway, yeah, that's all I have for this one. Let me know what you think. Hope y'all have a good contest later if you're doing it. If not, then I hope I get your good luck for your contest. I don't know. Anyway, stay good, stay healthy, take good mental health, take care of yourself, and I'll see y'all later. Bye bye.